Question 1. Let us try to visualize the possible number of formations given that we require at least 3 cadets in each column and at least 4 cadets in every row. So for the first way, suppose we have a total of 1, 2, 3 cadets in this column, which means that we need a total of 28 such columns because 28 times 3 gives us 84 cadets. So let us try to draw this out. We have one column of 3, 2 columns of 3, so on and so forth until we have a total of 28 such columns. 28 such columns. And from here, we see that in every row, we would have a total of 28 cadets per row. For the second way, we can also have a total of 1, 2, 3, 4 cadets in every column, giving us a total of 21 such columns because 21 times 4 gives us 84, and therefore we would have a total of 21 cadets per row. For the third way, we can have a total of 6 cadets in every column, giving us a total of 14 such columns and 14 cadets in every row. For the fourth way, we can have a total of 7 such cadets in every column, giving us a total of 12 such columns and a total of 12 cadets in every row. For the fifth way, we can also have a total of 12 cadets in every column, giving us a total of 7 such columns and a total of 7 cadets in every row. For the sixth way, we could also have a total of 14 cadets in every column, giving us a total of 6 such columns and a total of 6 cadets in every row. And for the seventh way, we could also have a total of 21 cadets in every column, giving us a total of 4 such columns and a total of 4 cadets in every row. And we notice that the number of cadets per row decreases from 28 to 21 to 14 all the way to 4, because we require at least 4 cadets in every row, which means that we could not decrease any further. Therefore, the total possible number of formations would be 7. Question 2. We require 48, 96, and 144 to be divisible by the number of packets because we want to maximize the number of packets. This means that we are supposed to find the highest common factor of 48, 96, and 144, which turns out to be equals to 48. So, if Tracy packed 48 candies equally in 48 packets, in one packet she would have 1 candy. And if she packed 96 sweets equally in 48 packets, in one packet she would have 2 sweets. And lastly, if she packed 144 lollipops equally in 48 packets, in one packet she would have 3 lollipops because 3 times 48 gives us 144. Therefore, the total number of items in each packet would be 1 plus 2 plus 3, giving us a total of 6 items. Question 7. We can first find the highest common factor of 54, 60, and 72, which turns out to be equals to 6. And this means that the total number of ways must not exceed 6. So let's find the first way. For the first way, we can have 6 such groups, which means that in one group we would have 9 chickens, 10 ducks, and 12 sheep, because 9 times 6 gives us 54, 10 times 6 gives us 60, and 12 times 6 gives us 72. For the second way, we can also have a total of 2 such groups, which means that in one group we would have a total of 27 chickens, 30 ducks, and 36 sheep. For the third way, we can have a total of 3 such groups, which means that in one group we would have a total of 18 chickens, 20 ducks, and 24 sheep. And for the fourth way, we can have a total of one such group, which means that in one group we would have a total of 54 chickens, 60 ducks, and 72 sheep. Hence, the total number of ways would be 4. Question 5. We know that bus A comes every 12 minutes, bus B comes every 9 minutes, while bus C comes every 16 minutes. So let's compare bus A and bus B. Since the lowest common multiple of 9 and 12 is equals to 36, this means that bus A and B would meet every 36 minutes. However, 36 is not divisible by 16, so let's increase by another 36, which gives us 72. But 72 again is not divisible by 16, so let's increase by another 36, and this gives us 108. Again, 108 is not divisible by 16, so let's increase by another 36, which gives us 144, and this time 144 is divisible by 16. This means that all three buses would come at the same time in every 144 minutes. And 144 minutes is equals to 2 hours and 24 minutes. So, if all three buses came at 7:45 a.m., when would be the next time all three buses come at the same time? And the answer would be 7:45 a.m. plus 2 hours and 24 minutes, which gives us 10:09 a.m. Question 5. We know that Ellen jogs every 2 days, Betty jogs every 3 days, and Colleen jogs every 4 days. Again, let's compare Ellen and Betty. The lowest common multiple of 2 and 3 is equal to 6, which means that Ellen and Betty would go jogging together every 6 days. However, 6 is not divisible by 4, so we try to increase by another 6, which gives us 12, and this time 12 is divisible by 4, which means that Ellen, Betty, Colleen would jog together every 12 days. So within a 60 days period, what is the most number of days that they would go jogging on the same day? So on the 12th day, they would jog together. This is the first time they jog together. On the 24th day, which is another 12 days later, they would jog together the second time. And another 12 days later, which would be the 36th day, they would jog together the third time. And another 12 days later, which is the 48th day, they would jog together the fourth time. And another 12 days later, which would be the 60th day, they would jog together the fifth time. Therefore, the number of days that they would go jogging on the same day would be a total of 1, 2, 3, 4, 5 days. Question 6. We are supposed to find the smallest possible sum of P and Q. Because we are supposed to minimize the sum of P and Q, we can try minimizing P and minimizing Q. Because P is divisible by 4, 5, and 6, the smallest possible value of P, which is divisible by 4, 5, and 6, would be equals to 60. And the smallest possible value of Q, which is divisible by 6, 7, and 8, would be equals to 168. Therefore, the smallest possible sum of P and Q would be 60 plus 168, giving us a total of 228. Again, for question 7, we are supposed to find the smallest possible value of y minus x. Again, we can try by finding the smallest or minimizing y, and at the same time maximizing x. So, y is a multiple of 3. and we want y to be as small as possible. So the smallest possible value of y that is at least 63 would be equals to 63. And we know that x is a factor of 63, which means that x should not exceed 63. So the maximum possible value of x would be also equals to 63. Therefore, the smallest value of y minus x would be 63 minus 63, giving us 0.